going to examine the role of solar heat gain coefficient on glazing. In your model, you should either be using the default glass or this custom glass. The custom glass was 0.25 solar heat gain coefficient, which means that 25% of the incident solar radiation is being transmitted to the interior. The default, if all this is not plugged in all the way up to here, the default would be shown in your, I'll show you where it's shown in a second. I'm going to do this. I'm just going to unplug this, and you can see the window construction is right here. And again, like in the last one, the window and the operable should be identical. And that is right here. You can see all the construction. So that default for my climate is 0.25, 25% solar heat gain coefficient. I want you to do a study to look at what happens if you change that solar heat gain coefficient to a very high solar heat gain. This would be the equivalent of passive solar heating, to a moderate solar heat gain coefficient at 30%, to a very low solar heat gain coefficient of 0.15. And so in order to simulate this, I would plug in there into the solar heat gain, make sure that the material is connected to the construction, make sure the construction is connected to the subsurface, and then make sure the subface is connected to the construction set. And then you should see that change here and here. So now I've got a 0.6 solar heat gain coefficient. And then make sure you change your run so you can keep track of this. Solar heat gain coefficient 60, and then hit simulate. Collect the data from the EUI by end use, and then paste it into the Excel spreadsheet so you can compare. To do the iterations of this, you'll just need to move this index to 30% and then 15%, and you'll be simulating all those. Don't forget to change these as you go to a different run, and then collect the data after each one. So that's pretty simple. The next one that I'd like you to examine is the role of exterior shades. You'll know that, or you'll notice, as we talked about in class, that the impact of the glass is a little bit different than the impact of horizontal or vertical or combination of those exterior overhangs. And so it affects the glazing, or the solar heat to daylight ratio. And it also affects when and how much the glazing in the zone is in shade. There's two fundamental ways that I would like you to look at shade here. Actually, there's three. Originally, we asked you to define any large shade, like from context buildings or large overhangs or trees, using these components here. So that should already be done. I'm actually going to disconnect this so it's a little, oops, wrong one. I'm going to disconnect that. So now the overhang is off that east side, just so it's a little bit clearer what's going on here. And I would like you to experiment with what happens first when you add shades just to the south side, and then what happens when you add shades just to the west side. And actually, you don't need to simulate what happens on the east side for this assignment, but you will need to speculate what would happen if you were to shade the east side. So in this case, let's see, this is the south side and this is the west side. So this is the one that I'm going to want to apply my shades to. in order to do that, let's see, all of these shades are going in here. So I want to unhook this, and I want to unhook this. So I just have the south shades. Oh, I see what I did. That's probably a bad idea. What I want to do is simulate all of these. So I'm going to do this. I'm going to put this. So we are exporting all of our glazing, but then our south side windows, I'm going to hook up to my exterior shades right here. And the exterior shades I can control using this. I'll explain this in a second, but the first thing I want to do is actually take this and hook it up to the subface, and then make sure I'm disconnecting this. Boy, this is kind of a mess. Sorry about this. Make sure you're disconnecting that, because you only want that one set of glazing and shades to go in. All right, so let's zoom in on the south side here. And the way this is set up is that it's taking the window in and it's pushing the window and the shade out. You have control here of the depth of the shade, so the size. This is in meters. It can be anything you like, but it should be greater than 0.3. And this has to do with the way that the program calculates shade through the zone, and having larger geometry is just easier for the program to be accurate. If you select a profile angle that is too large, then you'll never see any difference as you change the profile angle here. So if I have a very large 5-meter overhang, as I change this, nothing's going to happen. But if I have a smaller size, then as I change this, you'll get a higher and higher density of horizontal louvers, because what this is doing, this basically trigonometry, is taking in a list of profile angles: 75 degrees, 60 degrees, 45 degrees, and 30 degrees, and using that to create the distance between the shades. And you can check this. I like checking 45 degrees because, of course, the tangent of 45 is 1, meaning that if I've got a 45-degree angle, the horizontal and the vertical should be equal to each other. It should be equilateral triangle. And I can visually see that here, but you could prove it to yourself by baking the geometry and then actually measuring it. So so that's how this works, and it just creates its own automated overhangs wherever you're hooking up that window group to it. And if I wanted to switch to the west side, I could instead hook this one up, and I'd be on the west side. I have to remember to plug this one into here so that I still have those south windows. Yeah, and I would be good to go on the west side then. Okay, so the assignment asks you to simulate 75-degree profile angle, 60-degree profile angle, 45 and 30 on the south side, and then repeat for the west. And then on the west, I'm going to unplug this, plug it in. On the west side, here we go. After doing that for the south side, on the west side, I would like you to do the same thing, and then add a vertical shade to the horizontal one to create an egg crate design. So what I have got here is a second component that includes vertical shade. So I have to hook this up like this, and now I've got verticals in addition to horizontals. And just for simplicity's sake, simulate this so that they're the same depth, same profile angle and azimuth angle. At this point, you're going to get a pretty well shaded facade, I suspect, in almost all of your cases. Although you will get some moments right at sunset when you have sun coming in at very low angles. But yeah, it's a pretty well protected facade there. So see what that does, experiment with it, and report all of the different results for those angles. In the next tutorial, I will show you how to model dynamic shades. These are all static, so they're in one place and fixed. In the next tutorial, we'll be looking at how to make them move.